Alright, so next we go from moles to particles. Remember, that's what Avogadro's number is. It tells you, okay, 1 mole of this substance is 6.022 times 10 to the 23rd particles of that. Because, one atom, one atom of carbon would be either 12, 13, or 14. But if we're taking the weighted average, we say it's 12.01 AMUs. But if you have 1 mole of them, 6.022 times 10 to the 23rd, then you have 12.01 grams. So if you want to go from moles to particles, this is your conversion. Now, like I said, well, I don't know if I did mention this. In our class, we're going to use 6.022 times 10 to the 23rd. So sorry that it leaves off that other 2. But all you got to do, atoms to moles, you have 1.25 times 10 to the 23rd atoms in this question. I want to know how many moles that is. So since I have atoms, 6.022 times 10 to the 23rd particles, which in this case would be an atom because that's the particle we're looking at. So atoms in 1 mole. And all you'd have to do is divide those two, and that would be good. Sorry, I don't know what happened there. Very simple. Going the other way, you have moles, 2.12 moles of propane, and then you'd say, okay, well, 1 mole is 6.022 times 10 to the 23rd particles. In this case, what is the particle? Well, the particle is a compound. Ooh, so we're looking for atoms, and this is going to give us molecules, okay? This is going to give us the molecule particle. So when we multiply this out, so we got 2.12 times 6.022 times 10 to the 23rd, we're going to get 1.28 times 10 to the 24th, okay? Now here's where we can, keep going with dominoes, or you can start using something else. In this case, we have 3 carbons, 8 hydrogens, which is 11 atoms. So you just multiply this by 11, okay, because that's how many of this unit we have. So you multiply by 11 to get how many particles. Or we could have done 2.12 moles times 1 mole is 6.022 times 10 to the 23rd particles. And then we'd say 1 particle has 11 atoms. And so that will get you the answer of 1.40 times 10 to the 25th. The last thing is between moles and volume. Now this is only at something called STP, which you don't have to worry until later in the year. Everything's going to be at STP. That means standard temperature and pressure. But at standard temperature and pressure, 1 mole of any gas at all, 1 mole of it is going to take up 22.4 liters, okay? Standard temperature and pressure is 0 degrees Celsius and 1 atmosphere, okay? 1 atmosphere, but you don't, like I said, don't worry about that right now. We'll talk about that later. All you need to know is 1 mole of any gas takes up 22.4 liters at STP. Now, keep in mind, this is only for gases, okay? I can't say this enough. It's only for gas. Don't try to do this with a liquid or a solid. It won't work. It's only for a gas, and it's only for a gas if it says it's at STP. There's other things we have to do if it's not at STP that I'll teach you later. So, you have a volume. If you want the volume of a gas and you have moles, all you do is you say 1 mole is 22.4 liters. Very simple. If you have 0.6 moles, in this case, 1 mole is 22.4 liters. Multiply that out, and you got it. And you can go in either direction. I think that's a pretty easy one. This right here is a great resource. All right, the mole roadmap. Memorize this. It shows you which direction you're going. So like if I'm starting with mass and I want to go to particles, this is how I'm going right here. Okay, so I multiply by this first, 1 over the molar mass, and then by Avogadro's number over 1 mole, and you just follow it. It doesn't get any easier than that. Now, you can't use this on the test, but it can help you memorize, so I highly recommend that.